Okay, this one's going to be about cross-elasticity demand. It's not particularly difficult, but somebody's asked me to do it. So, cross-elasticity, and I think there is something that people tend to get wrong with this, which is that they tend to think it's to do with the relationship between the quantity of one product and the quantity of another, and that's not true. So its proper name really is cross-price elasticity demand. What it's trying to show is rightly the relationship between two products, but what it's trying to show is the relationship between the price of one product and the quantity of another, the quantity demanded of another. So if the price of one product goes up, what happens to the quantity demanded of another product? That's the point of cross-elasticity of demand. So, in terms of the formula, there we go. Oh, look at this! Look at this preparation. Yeah, I never get this right though. It's the percentage change in quantity demanded of product A divided by the percentage change in the price of product B, or whatever. But it's always, like with all elasticity formulae, it's always quantity on the top and something financial on the bottom. So, what possible relationships might there be? One possible relationship is the relationship between the iPhone, as shown here, and the U phone. So let's suppose that for the sake of argument, that there is a decrease in the price of iPhones. Then what's going to happen to the demand for other brands of phones? And the key thing to remember is that because the price of iPhone goes down, that'll mean there's more demand for iPhones, but therefore there will be a decrease in the demand for alternative products. So a decrease in the price of one leads to a decrease in the demand for the other, and what that gives us is it gives us a positive cross-elasticity demand, because the price and the demand are moving in the same direction. So therefore, if we've got substitutes, we have a positive cross-elasticity of demand relationship. And that's where people, kind of intuitively go wrong, because they go, oh, substitutes, they go against one another, it's going to be negative. Yeah, but it isn't. Because it's just showing the relationship between the price of one and the demand for the other, not the demand for one and the demand for the other. Obviously, the higher this relationship, the stronger the relationship is. So the bigger the value you get for cross-elasticity demand, the stronger these are as substitutes. The smaller the relationship, the weaker they are as substitutes. So alternatively, what we might have is a relationship where the products are complements, like an iPhone and the apps for it. So in this case, again, suppose that there is a decrease in the price of the iPhone. More people go out and buy iPhones, as a result of which they're going to need apps for them. Therefore, what we'll see is an increase in activity in the iTunes store, and what we see is that because price is lower, more people buy iPhones, therefore more people buy apps, and that is a negative correlation between the two. As the price of one goes down, the demand for the other one goes up. They're going in opposite directions. Therefore, we have a negative cross-elasticity. And likewise, what that means is that, like with substitutes, the stronger the number. So if a 10% change in price, fall in the 10% change in the price of iPhones leads to a 20% increase in the demand for apps, then they're strong complements. If we cut the price of iPhones by 10% and we get a 1% increase in the demand for apps, then that's a pretty weak relationship. So finally, our final relationship down at the bottom here might be between the price of apps and the demand for bananas. If there is a decrease in the price of iPhone apps, then I think we can all be reasonably content that there'll be no impact at all on the demand for bananas. Therefore, cross-elasticity demand relationship in this case is zero. There is no relationship. So when we have substitutes, cross-elasticity demand is positive. When we have complements, spelt with an E, then we have negative cross-elasticity demand. And if there's no relationship, well, funnily enough, there is no cross-elasticity. Cross-elasticity demand is zero. And that's pretty much it, really. That's all there is to say about cross-elasticity demand. It's pretty simple. I suppose you could show it if you wanted, you could try and show it on a diagram. You could say, well, if that's the price of iPhones and that's the demand for U phones, then as the price of iPhones go up, people switch away and they buy U phones. On the other hand, if the price of iPhones goes down or up, the quantity of apps, quantity demand for apps goes the other way. So as the iPhone gets cheaper, more people buy apps, and that's your negative. So that's why you have a positive cross-elasticity demand for substitutes, but we have a negative cross-elasticity demand for complements.